everyone, it's Mr. Spinelli. Today we're going to talk about solving quadratic equations graphically. So as you've probably already seen before, we've done it by factoring, which is the case when our solutions are either integer or rational values. And we've also used the quadratic formula. The quadratic formula works for any quadratic equation, whether our solutions are real or complex. Now, remember that when we're trying to solve an equation, some quadratic equation set equal to 0, we're looking for where this function here in red crosses the x-axis, which is where y equals 0. So the solutions to this equation are also known as x-intercepts, zeros, and roots. So when we start with the parent function y equals x squared, we have an a value of 1, a b value of 0, and a c value of 0. When that's the case, we only have one solution, and that's at 0, 0. So when x equals 0, y will equal 0. This is called a repeated root. Remember, there's three different scenarios. We can have no solutions, which is when the function does not cross the x-axis. We can have exactly one solution, which is when you have a so-called repeated root, or you can have two solutions. So notice if I just shift the parent function up and down by changing the c value, I go from no solution to one solution to two solutions. Now as I change the a value and leave b and c still 0, I'm just going to change the width of the function and whether it's concave up or concave down. And again, I still have a repeated solution of x equals 0 in all of these scenarios. Now as I change c, that's where I begin to have 0, 1, or 2 solution. As I change the b value, you'll notice that my roots simply move around depending on where I am. So the goal is to find where the function crosses the x-axis. Now, the other thing you'll notice is that my goal is usually to find also where this function has a maximum or a minimum. And in order to do that, when I'm given this function in standard form, ax squared plus bx plus c, I need to look for the axis of symmetry. And in order to find that, I need to compute negative b divided by 2a. So in this case, I would take 3.3 and divide it by 4.6, which is 2.3 times 2. And then I need to make that result negative, which would give me negative 0.72. And when I plug negative 0.72 back into the function as the x value, I get a y value of negative 2.08, which is where my vertex is. So whenever you're given a function in standard form, it's common to solve it using either the quadratic formula or graphically by looking for where it crosses the x-axis. And another important piece of information when given something in standard form is to find the vertex, which we do by computing negative b over 2a to get the x-coordinate, plug that back into the function to get the corresponding y-coordinate. So again, regardless of what your a, b, and c value are, you just need to look for where the function crosses the x-axis. Thank you for watching and have a great day.